welcome to Science Learning Gateway. I hope you all are doing good. So today we are going to discuss chapter number 12 from CBSE term 2 syllabus, and the name of the chapter is electricity, and we are going to complete this chapter in one shot. So let's get started with the lesson electricity. So first of all, we will read what is electricity. Electricity is the branch of physics which deals with the study of charges. What we have to read in electricity, we have to read about the charges, and there are two types of electricity: static electricity and current electricity. About this electricity chapter you are going to read in your plus 2 when you'll go to 11th and 12th standard. Over there the same chapter is there, but over there you'll read this electricity chapter in detail. Now let's read about the electric charge. An electric charge is represented with the alphabet capital Q. The charge is the fundamental particle in an atom. It is of two types, positive and negative. So what is electric charge? It is the fundamental, means in all the atoms charge is present, and there are two types of charges, positive charges and negative charges. Like charges repel each other, unlike charges attract each other. This is one of the property of charge. Like charges, if plus charge will come together, they will repel each other, they will move far away from each other. But if plus and negative charge will come, means unlike charges will come, they will attract each other, they will come close to each other. Now what is the SI unit of charge? This is also very important. It can come in your multiple choice questions also, or it can come for one marks question also. So the SI unit of charge is coulomb, represented with the letter capital C. Represented with the letter capital C. SI unit of charge is coulomb. Remember that. Next we have electrons carry a negative charge. As you know that electrons are negatively charged particles and protons are positively charged particles, and neutrons, they don't have any charge. So electrons carry a negative charge of minus 1.6 into 10 to the power 19 coulomb, and protons carry a charge of plus 1.6 into 10 to the power minus 19 coulomb. Both electrons and protons will carry same charge, but only difference is because of the sign. Electrons will carry a negative charge and protons will carry a positive charge. Now what is the value of 1 coulomb of charge? The value of 1 coulomb of charge is 6 into 10 to the power 18 electrons. And charge on 1 electron is equal to negative charge of 1.6 into 10 to the power minus 19 coulomb. Means how much charge is present in an electron? Minus 1.6 into 10 to the power 19 coulomb. And one formula over there which we have to read is charge Q is equal to N into E, where N is the number of electron and E is the charge on 1 electron, right? So if the numerical will come, calculate the charge present on 5 electrons. So number of electrons will be 5 over there, and charge on 1 electron is minus 1.6 and into 10 to the power minus 19. If you multiply that, you will get the value of the charge. Now next topic which we have to read is electric current. And electric current is represented with the letter capital I. So what is electric current? The rate of flow of charge is called current, right? The rate of flow of charge is called current, and we used to represent current, means we used to write the formula of current: I is equal to Q by T. This is the formula for current. I is equal to Q by T, where I is the current, Q is the charge, and T is the time. So current is equal to charge by time. Rate of flow of charge is called current. SI unit of current is ampere, and the symbol for current is this one. You have to put one circle at in the center. You have to write capital A plus and negative sign. So SI unit of current is ampere, denoted with the letter capital A. Current is measured by an instrument. Like for example, different instruments we have for measuring different things. Like for example, for measuring temperature we have different thing. For measuring the purity of a substance we have different thing. For measuring pressure we have different instrument. In the same way, for measuring current we have an instrument called ammeter. AMMETER, ammeter, and its symbol is this one. This is the symbol of ammeter. This is the symbol of ammeter, capital A with plus and minus sign. Ammeter has low resistance and always connected in series. When you see the circuit diagram, you will see that ammeter is always connected in series. It will always be connected in series. Why ammeter is connected in series? Because it has low resistance. Now the next topic or the next physical quantity which we are going to read is potential difference, denoted with the letter capital V. Potential difference is denoted with the letter capital V. So what is potential difference? It is a work done to move a unit charge from one point to another point. Means potential difference is that work done which is used to move a charge from one point to another point. For example, we have to move a charge from point A to point B. So that will be our potential difference, the work done which is used to move a charge from one point to another point. So V is equal to W by Q, where W is the work done and Q is the charge. Okay, potential difference V is equal to W by Q. So remember this formula, V is equal to W by Q, work done divided by charge. Suppose in the question it will be asked, calculate the potential difference where the work done is equal to 5 joule and your charge is 6 coulomb. So using this formula you can easily calculate the potential difference, and the SI unit of potential difference is volt, VOLT, volt. Now what is the definition of 1 volt? Since we have written this formula, potential difference V is equal to W by Q, right? So 1 volt is equal to for volt we can write the SI unit as V, and for what is the work done for what is the unit for work done? It's joule, and for charge we have coulomb. So the definition of 1 volt will be when 1 joule of work is done in carrying out 1 coulomb charge, then potential difference is equal to 1 volt. This is the definition of 1 volt, right? And the symbol for voltmeter, this is the symbol for voltmeter. Now, potential difference is measured by an instrument. Like for example, a meter we use to measure for current, and potential difference is used for measuring. Potential difference is measured by an instrument called voltmeter, and the symbol of voltmeter is this one. You have to put capital V inside the circle, plus and minus sign. It has high resistance and connected in parallel. Just now we have read that a meter has low resistance and connected in series, but voltmeter has high resistance and connected in parallel. This is the difference between a meter and voltmeter. If the question will be asked, what are the differences between a meter and voltmeter, you can easily write that a meter is always connected in series combination, voltmeter is connected in parallel combination. A meter has low resistance, potential difference has high resistance. Next, what we have that a meter is used for measuring the current and voltmeter is used for measuring the potential difference. Cell is the simplest device to maintain potential difference. Okay, one cell, you all know what is a cell, and it is the simplest device which can maintain potential difference. Current always flows from higher potential to lower potential. Yes, when you look at the circuit diagram, you can see that current will always flow from higher potential to the lower potential. Okay, so now let's learn about some of the symbols of commonly used components in circuit diagram. This question can come that draw the symbols of an electric cell, draw the symbol of a meter, draw the symbol of voltmeter, or it can come in the form of MCQ also. They will give you the symbol and you have to answer that this symbol is used for representing which component in the circuit diagram. So for cell we use this symbol, a minus sign and a plus sign is there in this one. Combination of cell, what do we call? If 2 or 3 cells are there, then it's a battery. Next, if the plug key is on or it's open, then the symbol will be like this, and if it is closed, then one dot will be there in the center. Wire joint, this diagram is there, you can see over there. Wire crossing without joining, so for that you will draw one line and you have to draw like this. For bulb, it's very easy, bulb is like that. And for resistance, the symbol is like this, zigzag line with a straight line. And for rheostat or variable resistance, you will draw a resistance and after that you will put one arrow. Next, a meter and voltmeter already we have discussed. So these are the symbols for some of the components which can come in your exam. Now, the potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided that temperature remains constant. So this is your Ohm's law. This is your Ohm's law. Ohm's law. So this is very important. Many times this question was asked that state Ohm's law, define Ohm's law. So what you write, the potential difference across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided that temperature remains constant. Means suppose one circuit is there. Over there, the potential difference across the wire V is proportional to the current which is flowing through the circuit. And what is the condition? That temperature should be constant over there. If you remove the proportionality sign, one constant will come, and over there the constant is R. So your mathematical form of Ohm's law will be V is equal to IR. You can see over there, right? And R is equal to V by I. R is equal to V by I. And this R is known as resistance. R is known as resistance. Now let us learn about the definition of resistance. It is a property of a conductor to resist the flow of charges through it. So what is resistance? It is a property of a conductor to resist the flow of charges through it. Means this resistance will not allow the charges to flow through the conductor. It will stop that charges to flow through the conductor. And the SI unit of resistance is ohm. And the symbol of ohm is like this. The symbol of ohm is like this. This is the symbol of ohm. So 1 ohm is equal to 1 volt divided by 1 ampere, because the unit of resistance is ohm, and the unit of potential difference is volt, and the unit of current is ampere. So 1 ohm is equal to 1 volt divided by 1 ampere. Now let us define 1 ohm. So when potential difference is 1 volt and current flowing through the circuit is 1 ampere, then the resistance is 1 ohm. This is the definition of 1 ohm. Now let us read about variable resistance and rheostat. So what is variable resistance? Variable resistance is the component used to regulate current without changing the source of the voltage. Okay, so this is the definition of variable resistance. It will regulate the current without changing the source of the voltage. Next is rheostat. In an electric circuit, a device called rheostat is used to change the resistance in the circuit. Suppose you want to change the resistance in the circuit, then you can change the resistance of the circuit using a device called rheostat, which is used for changing the resistance in a circuit. Now let us read about the factors factors on which resistance of a conductor depends. So this is also important question. Sometimes this question is asked, write the factors on which resistance of a conductor depends. Right? So see, first factor, resistance of a uniform metallic conductor depends on. First of all, the resistance of a conductor is directly proportional to the length of the conductor. Resistance of a conductor is directly proportional to the length of the conductor. Second is, resistance of a conductor is inversely proportional to area of cross section. And third one, resistance of a conductor depends on nature of the material. It will also depend on the nature of the material. So if we combine both the equation, we can write resistance R is proportional to L by A. If you remove the proportionality sign, is equal to rho L by A. If you remove the proportionality sign, you will get a constant called rho, and this rho is called resistivity. It is a constant of proportionality called resistivity. So that there are three factors on which resistance of a conductor depends. It depends on the length of the conductor, and it is inversely proportional to area of cross section. If we will increase the area of cross section, resistance will decrease, and if we increase the resistance, area of cross section will decrease. Combining both the equation, we will get resistance R is proportional to L by A, and when you remove the proportionality sign, you will get R is equal to rho L by A, where rho is called resistivity. Now, let us read about resistivity. What is resistivity? It is a fundamental property of a material that resists the flow of electric current. Okay, if resistivity, what it will do? It will not allow the electric current to flow, which resists the flow of electric current. SI unit of resistivity is ohm meter, and the symbol is like this, ohm meter. For resistance, we have read that the symbol was ohm, but for resistivity, the symbol is ohm meter. Resistivity does not change with change in length or area of cross section, but it changes with change in temperature. Means resistivity, that is your rho, will not depend on the length of the conductor or area of cross section, but it will depend on the temperature. If temperature will be changed, resistivity will also change. Range of resistivity for metals and alloys is 10 to the power 8 ohm meter to 10 to the power minus 6 ohm meter, and resistivity for glass and rubber is 10 to the power 12 to 10 to the power 17 ohm meter. Resistivity of alloys are higher than metals and they do not oxidize or burn at higher temperature. Because of this reasons, alloys are used in electrical heating devices like electric iron, toasters, etc. So from here, one reasoning question you can get, that why alloys are used in heating devices like electric iron, toasters, etc. So what is the answer which you have to write? That resistivity of alloys are higher as compared to metals and they will not oxidize or burn at higher temperature. Because alloys cannot burn at higher temperature, that's why they are used as they are used in heating devices like electric iron, toasters, etc. Tungsten. Do you know inside the bulb, the bulb of the filament is made of a metal called tungsten, and the melting point of tungsten is very high. That's why it will also not melt at higher temperature. Copper and aluminium are used for electrical transmission lines as they have low resistivity. And even you have seen that in the electrical wires, copper and aluminium are used. Why? Because they have low resistivity and they will also not burn at higher temperature. The next factor which we are going to read is resistor. What is resistor? A resistor is an electrical component that limit or regulate the electric current. Okay, it is one of the component which limit or regulate, means it will regulate the electric current flowing through the circuit. Example, fan and television. Resistors are present in fan and television. Resistor in series we will read, and two types of combination we will read over there: series combination and parallel combination. When two or more resistors are connected end to end, the arrangement is called series combination. Series combination means like this: this is one of the resistor, and if this is one of the resistor, then they are connected in series. End to end combination is called series combination. Total resistance Rs is equal to R1 plus R2 plus R3 and so on. Suppose the resistance is R1 over there and this is R2. So total resistance of the circuit will be R1 plus R2 plus R3 plus R4. Depends on how many resistors we have. In series combination, the current through each resistor is same. Yes, this is also one of the important point. Suppose this is a circuit diagram in which this is your series combination is shown over there. So in this circuit, in series combination, the current flowing through all the resistors will be same. Same current will flow through R1, same current will flow through R2, and same current will flow through R3 also. Okay, same amount of current will flow through all the resistance. Total potential difference V is equal to sum of potential difference. But over here the potential difference can be written as V1, V2 and V3. Applying Ohm's law. So when we apply Ohm's law over there, so if we suppose three potential differences are there, so how we will get the total potential? By adding all the potential difference. So we have read in Ohm's law that V is equal to IR. So in place of V we can write V we can substitute IR, and in place of IR we can write IR1, IR2 and IR3. II will be common, II cancel, and at last total resistance R is equal to R1 plus R2 plus R3. Suppose three resistors are connected in series, then you will get the total resistance by adding all the resistance R1 plus R2 plus R3. Now let us read about resistors in parallel combination. Reciprocal of equivalent resistance is equal to sum of reciprocal of individual resistance. Suppose 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. This is the value of resistance in parallel combination. Equivalent resistance is less than the value of smallest individual resistance in combination. Voltage across each resistor is same and equal to the applied voltage. Total current is equal to sum of current through the individual circuits. See, in parallel combination what happens, that the voltage will be different in all the resistors. For first resistor the voltage will be V1, for second one the voltage will be V2, and the voltage will be same. The voltage means that potential difference V will be same through all the resistors, but current flowing through each of the resistors will be different. It will be I1, I2 and I3. Now let us read some of the advantages of parallel combination over series combination. So this question can also come in the exam, that what are the advantages of parallel combination over series combination, or it is also asked that why the circuits or why the electrical component should be connected in parallel combination, right? So the first question is first point is, in series circuit, if one component fails, the circuit is broken and none of the component works. See, if you will connect fridge, TV, AC in all in the same line, end to end combination, what will happen? If one of the component will fail, other components will also not work. Second one, different appliances have different requirements of current. This cannot be satisfied in series as current remains the same. Yes, for example, fan, the requirement for current for fan is different, the requirement for current for AC is different, and the requirement of current for bulb is different. If we connect all the three things in the series combination, you know that in series combination the current remains same, but all the appliances need different amount of current, so series combination is not possible over there also. Parallel circuit divide the current through the appliances. Each appliances get proper current depending on its resistance. But in parallel combination, what we have read, that the current flowing through each and every resistance or the component will be different. So the all the appliances will get proper current and it will work properly. In parallel combination, it is very easy to connect or disconnect a new appliance without affecting the working of the others. Yes, in parallel combination, it is also there is a possibility that you can add any of the appliances, or you can remove any of the appliances, right? And it will not affect the working of other appliances. So these are the important advantages of parallel combination over series combination. Now let us read about the heating effect of electric current. See, in an electric circuit, if an electric circuit is purely resistive, the source of energy continuously get dissipated entirely in the form of heat. This is known as heating effect of electric current. Suppose any electric circuit is a resistive in nature. So the energy which the circuit is getting means the energy which will come out from that circuit will be in the form of heat, and this is called heating effect of electric current. Energy E is equal to P into T, power into time, right? So this P we can write as V into I. Power P is equal to V into I into T. So heating effect H is equal to V into I into T. V into I into T. So in place of V we can write IR. So I will become I square RT. I square RT. The heating effect H is equal to I square RT. This is the definition of heating effect of electric current. Now we will read about Joule's law of heating. It is also one of the important topics. State Joule's law of heating. So it states that heat produced in a resistor is directly proportional to the square of current for a given resistance. H is directly proportional to the square of current flowing through the resistance, directly proportional to the resistance for a given current, and it is also directly proportional to the resistance and directly proportional to the time for which the current flows through the circuit. It is also proportional to the time. So H is directly proportional to I square R T. So if you remove the proportionality sign, H is equal to I square R T. This is the statement of heating effect of electric current. This is a statement of heating effect of electric current. Okay, so what does Joule's law of heating tell us? That states that heat produced in a resistor is directly proportional to the square of current flowing through the resistance, directly proportional to the resistance, and directly proportional to the time for which the current flows through the resistor. So H is equal to I square R T. Now we are going to read about the practical applications of heating effect of electric current. Heating effect is desirable in devices like electric iron, electric heater, electric oven, and electric fan. Yes, heating effect is used in all the devices like iron, fan, heater, etc. Heating effect is undesirable in devices like computer, television, refrigerator, but this heating effect cannot be used in computer, TVs, and refrigerators. In electric bulb, electric heating is used to produce light. Yes, bulb is used a bulb, when we switch on the bulb, we get light. And the tungsten, which is used is for the making the filament of the bulb, the melting point of tungsten is 3380 degree Celsius, is used for making filament of bulb because its high melting point and does not oxidize at high temperature. So why tungsten is used for making the filament of the bulb? Because it is having very high melting point and it will not burn at high temperature. Inactive gases like nitrogen and argon are used to fill the bulbs to prolong the life of the filament. Now inside the bulb, which gas is present? Nitrogen gas or argon gas is present, so that the life of the bulb will be more. Most of the power consumed by the filament appears as heat, but a small form of it is in the form of light radiated. Yes, when bulb give us energy, most part of the bulb is given to us as in the form of heat, but very small fraction of it will give in the form of light. Now we are going to read about electric fuse and electric power. See, so what is electric fuse? Electric fuse is a safety device that protects our electrical appliances in case of short circuit or overloading. So what is a fuse? It is a safety device which protects our electrical appliances from short circuit and overloading. And fuse is made up of pure tin or alloy of copper and tin. Fuse is made up of, it can be made up of pure tin or it can be made up of alloy of copper and tin. Fuse is always connected in series with live wire. Okay, the fuse is always connected in series with the live wire. Fuse has low melting point. Fuse, if you use a fuse in your house, you can see that in fuse low melting point is there. Why? Because if suppose any short circuit will occur, it will melt easily and the circuit will be broken down and you can be saved. Current capacity of fuse is slightly higher than that of the appliances. It is also true that the current capacity of fuse is slightly higher than that of the appliances. Now we are going to read about the electric power. It is represented by the letter capital P. The rate at which electric energy is consumed or dissipated in an electric circuit is called electric power. So what is electric power? The rate at which electric energy is consumed. Okay, the rate at which electric energy is consumed in an electric circuit is called electric power. P is equal to VI. This is one of the formula for power. Potential difference into current. Again we can write P is, in place of V we can write IR, and again I is there. So I into I will become I square R. I square R. Or you can write P is equal to V square by R also you can write. SI unit of power is what? Remember this one, SI unit of power is what? It is the power consumed by a device that carries 1 ampere of current when operated at a potential difference of 1 volt. So what is 1 watt power? 1 watt power is the power consumed by a device when it carries 1 ampere of current when operated at a potential difference of 1 volt. Now 1 watt is equal to 1 volt into 1 ampere. 1 watt is equal to 1 volt into 1 ampere. Commercial unit of electrical energy is kilowatt hour. What is the commercial unit of electrical energy? Kilowatt hour. kWh. So 1 kilowatt hour is equal to 1 watt. 1 watt into 3600 seconds. 3.6 into 10 to the power 6 watt seconds. That is will be equal to 3.6 into 10 to the power 6 joule. And 1 kilowatt hour is equal to 1 unit of electric energy. So in power you have to remember the definition of power, the formulas, and also the SI unit of power. Now at last we are going to discuss few of the important formulas which will help you out for solving the numericals. The first formula which we have read is electric current I is equal to Q by T, charge by time. And what is the SI unit of current? The SI unit of current is ampere. Second one, potential difference V is equal to W by Q, and the SI unit of potential difference is volt. V is equal to IR according to Ohm's law. Then resistance R is equal to rho L by A, where R is the resistance and rho is the resistivity. Series combination R is equal to R1 plus R2 plus R3, and in parallel combination 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. And heat generated H is equal to VIT, or you can write as I square RT. Power P is equal to E by T, and the SI unit of power was watt. P is equal to VI, P is equal to I square R, P is equal to V square by R. So these are the formulas which will help you out to solve all the numericals related to your electricity chapter. So go through the formula once and practice the numericals according to that. Read the questions properly and then understand that what physical quantity you have to calculate in the question. Then recall your formulas, that which formulas you have to use. Write the formula, put the values in the formula, and then solve the question. So I hope you all have understood this chapter electricity. It's not so complicated. Only thing is that you have to remember the small things which are given in the question, like SI unit, definitions, Ohm's law, what is Ohm's law, what is Joule's law of heating, then what is the advantages of parallel combination over series combination, what are the SI units of power, potential difference, current, etc., and the also the symbols of the electric component. If you'll do these things, you can definitely get full marks in this chapter. And also don't forget to solve the numericals. So thank you for watching my channel Science Learning Gateway. If you are new to my channel, then please subscribe to it, and don't forget to click the bell icon so that whenever I will be uploading a new video, you'll get the notification for that. And if this tutorial is helpful for you, then please click on the like button, share it with your friends also. So thank you for watching a lot, and I wish you all a very good luck and all the best for your coming board exams.